This question is about a simulation of queue. The question goes like this. Observations of past data show the following patterns in respect of inter-arrival duration and service duration in a single channel queuing system. Using the random number table given below, simulate the queue behavior for a period of 60 minutes. Assume that the queuing system starts at 9 hours and estimate, number 1, the probability of service being idle. Number 2, mean time or the average time spent by a customer waiting for service. Number 3, average number of customers in the queue. And number 4, average number of customers in the system. So here, inter-arrival time between first arrival and second arrival, or second arrival and third arrival, like that average inter-arrival time is being calculated, and it is given in this data. For 2 minutes, the inter-arrival time to be 2 minutes, the probability is 0.15, and if it is 4 minutes, means its probability is 0.23, like that. They gave us different probabilities for different inter-arrival time. Similarly, service time ranges from 1 to 9, and for that different probabilities are given. Then random numbers starting at northwest corner and proceed along the row, that is first 2 random numbers for the first trial, etc. Like that, random numbers are also being provided. So based on this data, that is inter-arrival time and service time and the random numbers, we need to start with our simulation. So solution. The cumulative probability distribution and the random number interval for inter-arrival and service time are computed as below. So first of all, inter-arrival time, the same data, minutes and probability is written here. Then we calculate the cumulative probability. First one will be 0.15 only. Then 0.15 is getting added to this 0.23 to get this 0.38. Then 0.38 is getting added to this 0.35 to get this 0.73. Likewise, it goes up to cumulative probability of 1. Now, for the first cumulative probability, the random number range, since all that random numbers are in terms of 2 digits, we are starting with 00 as the first random number. And since it is up to 15%, up to 15, so we need 15 random numbers here. So it starts from 00 and ends with the number prior to 15, which is 14. Then it starts from 15. Here it is ending at 38. So we'll consider a number which is prior to 38, which is 37. Like that, we assign random numbers here. Similarly, for service time, we are copying this data, that is 13579, and the probabilities here, same thing. Then we calculate the cumulative probability, similar to how we did for inter-arrival time. Then we again assign random numbers for these minutes, like this 00 to 09, 10 to 31, like that. So we can start now the simulation activity. The question says that we need to consider the random numbers as northwest corner, means starting from 93, next random number will be 71, then 14, then 63, like that. Means 2 random numbers for the first trials, means 93 is meant for inter-arrival time, 71 is meant for service time, 14 is meant for inter-arrival, 63 is meant for service. Likewise, we'll be entering the data here, 93, 71, 14, 63, and then 72, 14. So we enter the random numbers here. Now, the first random number which is meant for inter-arrival time, it is 93. So you go to that inter-arrival times probability distribution. Here you look for this number 93. 93 is lying between 90 to 99. So the corresponding inter-arrival time is 10. So we go there and enter 10 over there. Similarly, for the next random number, which is 71 for service time, we go to service time probability distribution. 71 lies between these two. So the corresponding minutes is 7. So we enter 7 here. Likewise, we capture the inter-arrival time in minutes for all the random numbers meant for inter-arrival time and all the random numbers meant for service time, and we enter the service time here. By referring to these 2 tables, we do that. Now, the question says that the system is starting at 9 o'clock or 9 hours, which means the counter is open at 9 o'clock, but the first inter-arrival is 10 minutes, which means the first arrival starts at 9:10 only. 9 hours plus 10 minutes. It starts at 9:10. Then the service taken is 7 minutes, which means the service is getting ended at 9.17. Now, the server, whomsoever is servicing, he is waiting for the first 10 minutes because only after 10 minutes only the first arrival is happening. That means the server is waiting for the first 10 minutes. Whereas the first customer do not wait for any time. Immediately as soon as you enter, the service starts. So it is a zero waiting time for the first customer. Then a number of customers in the queue. The person, as soon as he reaches the counter, he is not waiting in the queue. He is immediately getting service. So there is nobody in the queue you will be considering. But since he started getting service, you will consider that one person to be in the system. So here, number of customers in the queue is 0 because the person is not waiting in the queue. Immediately he started getting service. Whereas in the system means one who is getting serviced also is considered to be in the system. So that is why it is 1. Then the next second arrival is happening after 2 minutes, which means first arrival came at 9:10. That means 2 minutes means this becomes 9.12 and the service is taking 5 minutes. Now, the service ends at 9:17. So here the service starts at 9:17 only. And then it is going to take 5 minutes. So that becomes now 9.22, means the service ends at 9 hours and 22 minutes. It gets end. Server is not waiting for any customer because server is now on and he is busy now. So there is a 0 waiting time for the server. And waiting time for customer here in between 9:12 to 9:17, the second customer is actually waiting. So he is waiting for 5 minutes. And since that person is waiting, there is a queue. I mean, the person is there in the queue waiting for the service to happen. So here the first customer is getting service and also this customer is in the queue. That means totally in the system, there are 2 people who are involved. That is why number of customers in the system is 2. Next, here the next arrival is happening after 6 minutes, which means 9:12 plus 6, it becomes 9:18 and that is going to take 3 minutes. Now this service is getting ended previously at 9:22. So the service can start only at 9:22 and it is going to take 3 minutes. So it becomes 9.25 here. Server is again not idle. Server is busy only. Whereas customer is waiting here 9:22 and 9:18. 4 minutes the customer is waiting. And that customer is there in the queue. And already the other customer is also getting service. That means totally there are 2 customers in the system. So here for this next arrival is happening after 2 minutes. That means 9:18 plus 2, it is 9:20. Whereas this particular service is getting ended at 9:25 only. That means the new customer can get service only at 9:25. And that is going to take 5 minutes. That means it is ending at 9.30. No server waiting time. Whereas the customer is waiting for 5 minutes because 9:20 and 9:25, the gap is nothing but the waiting time. Since that customer is waiting, you consider one person in the queue and the other person who is getting service, you consider 2 customers to be in the system. Next customer is arriving at after 4 minutes, which means 9:20 plus 4, it is starting, arrival happened at 9.24. Okay. Then this particular customer service gets ended at 9.30 and it is going to take 5 minutes for the next customer to get service. So it is 9.35. Server is busy, so no waiting time for server. Whereas the customer is going to wait 9.24 and 9.30. That means 6 minutes this customer is waiting. That customer, since he is waiting, he is there in the queue and one customer is already getting a service done. That means 2 customers are there in the system during that particular period. Then comes next arrival is happening after 8 minutes. That means 9.24 plus 8, it becomes 9.32. And this previous customer service is getting ended at 9.35. That means here the service can start for this customer at 9.35 only. And it is going to take 5 minutes for the service to happen. That means the service will get ended at 9.40. Server is completely busy, so no idle time or waiting time for the server. Whereas this customer, he came at 9.32, whereas his service starts at 9.35. That is why the gap of 3 minutes he is waiting. Since that person is waiting, he is in the queue, and already one more person is getting service when this customer is waiting. That means totally 2 customers are there in the system. Next customer is arriving after 8 minutes, which means 9.32 plus 8, it becomes 9.40. And the previous customer's service is getting ended at 9.4. That means there is no waiting time for the customer. Immediately the service is getting started, and it is going to take 1 minute for the service to happen. It becomes service gets ends at 9.41. Server is also not idle. Customer's waiting time is also not there in this case. So nobody is there in the queue because the customer is immediately getting service done. So that means only one customer is there in the system. Then next customer is arriving after 10 minutes, which means the arrival starts at 9.50, means 9.50, the next arrival is happening. And previous customer, service ended at 9.41, which means 9.41 to 9.50, the server is waiting for 9 minutes, whereas at 9.50, the service is immediately getting started. That means there is no waiting time for the customer, and it is going to take 5 minutes. That means the service gets ended at 9.55. So there is no customer waiting time, but there is a server waiting time for 9 minutes. What is that 9 minutes? Here the gap 9.41 and 9.50. That is why the server waiting minute is 9 minutes. So this customer is not waiting, so nobody is there in the queue. Whereas that customer is already getting service done. So in the system, there is one customer. Next arrival is happening at 6 minutes, after 6 minutes, which means arrival at 9.56. And the previous service ended at 9.55. Whereas here the arrival only is happening at 9.56, which means that it indicates that the server is waiting for 1 minute here, whereas no customer waiting time. That is why here it is 0. And since it is taking 5 minutes for the service, the service ends at 10.01. We are stopping our activity here because it is said in the question that we need to do simulation for 60 minutes only. Since 10.01 exceeded 60 minutes, we are stopping the simulation at this juncture itself. That means the rest of the random numbers we are not utilizing. Up to 38 only we had chosen. The rest of the random numbers we had not chosen at all. Right. Next, if you look into this, there was a waiting time for the server 9.55 and 9.56. That is why 1 minute is written, whereas the customer is not waiting. So it is 0 waiting time for customer. So no, sir, nobody is there in the queue, but one person is there in the system. Now we can add all this service time, which we get 41 minutes. Waiting minute of server, we can add these. We get what, 20 minutes. Waiting time of customer, we add all this, we get 23 minutes. Number of customers in the queue, we add all these numbers, we get 5. Number of customers in the system, we add all this, we get 14. Now, the questions we can able to answer now. First question is probability of service being idle. We may notice it is nothing but the waiting time divided by the total time of the server. Means 41 minutes he was actually working, and for 20 minutes he is idle. So that needs to be added two things, total service time or total server time. So 20 divided by 61 will be your probability of service being idle. Then mean time, that is the average time spent by a customer waiting for service. We may simply add, we already added this 23, and since these are 9 trials, you are dividing it by 9 to get this 2.56 minutes as the mean time spent by customer waiting for service. Then average number of customers in the queue is this total, that is 5, divided by number of customers 5, which we get 0.56. Since average number of customers cannot be in decimal, we are approximating it to one customer. Average number of customers in the system, this 14 divided by 9 customers totally, because these are all 9 trials. So when we do that, we get 1.56, which is rounded off to 2 customers. So these are the 4 questions which are asked. Those questions are being answered based on this simulation activity.